So today we'll be learning about derivatives. So first, let's look at the derivative of a constant. So d over dx of any constant is always going to be 0. That is rule number 1. That's pretty self-explanatory. So for any constant, aka any number, the derivative is always going to be 0. So for example, we have d over dx over 5. What's the derivative of this going to be? Yep, you guessed it. It's going to be 0. How about a much larger number? Let's say we have d over dx over a million. In this case, it's going to be the same answer, because any number, the derivative is going to be 0. So what is a derivative? Well, a derivative is a function that gives you the value of the slope at some x value of the original function. So with that in mind, let's take a look at why the derivative of a constant is always going to be 0. So if we have a grid like so, and we have a constant. So for example, if we have 5, right, and we have a straight line at 5, the graph is going to look like this. Right, this is our function f of x, let's say. And so in this graph, there is no slope. The slope is 0, right? And what is slope? So if you forgot, slope is essentially y over x, or also known as rise over run. Well, we're not rising anything. It's always staying constant on the x, right? So the y is always going to be 0. And 0 divided by any number is always going to equal 0. So that is why the derivative of any constant, whether it be 5 or a million, is always going to be 0. So now let's take a look at the derivative of an exponent. So if we have something like so, what is the derivative of this function going to be? The dx of this function. What's that going to be? Well, that's a different one. We know it's not going to be 0 because it's only with constant. So let's take a look at this. For this, there's a generic formula. Instead of x to the square, let's do a very generic formula of x to the n representing any exponent, such as 2. So the derivative of that is always going to be n. So we bring down the exponent to the front as a coefficient to the x, so the x stays on this, and the exponent becomes n minus 1. So whatever number n represents, such as 2, we subtract that by 1. And that is going to be the derivative of any exponents. So let's give this question a try. Okay, so we have d over dx, so we have to find the derivative of x squared. So what's step number 1? We bring down the exponent to the front, right? And so that is going to be 2 in the front. And we write the x as it is. And for the exponent, we do n minus 1. So it's going to be 2, that's what n represents, minus 1. And we can simplify that further to be 2x to the 1, or even if you don't write anything, it's implicit as 1. So the derivative of x squared is going to be 2x. What if it's a different exponent on top? Let's take a look at that. If it's x to the power of 4, well, when numbers are different, it's going to be the exact same thing. We bring down the exponent to the front, so it's going to be 4x, and we do n minus 1, so it's going to be 4 minus 1. And we can simplify that to 4x cubed. So anything with the exponent is always going to be the same exact rule that we looked at before. Now let's change it up a bit more. Let's say we have a coefficient beforehand. Also, we have a 3 here. Now, how is that going to change up the question? Let's take a look. Okay, so we have the 3 in front, but we have the x to the 4. Well, what do we do? Well, we do the exact same thing. We make sure to keep the 3 aside until we need to use it. So let's do exactly that. And we could put a square bracket to deal with whatever the exponent is. So what's x to the 4, the derivative of that? Well, it's going to be 4. We bring that to the front, multiply by x, and we do 4 minus 1. It's going to be 3, just like we had before. But now what we do is we multiply the coefficient that we had initially and the 4 that we brought up to the front. So what's the difference for? It's going to be 12x to the 3. And that's going to be derivative of this. So all we do if there's a coefficient is we keep it aside until we find the derivative of the exponent, and then we multiply both of the coefficients together to get the answer. You can pause the video for a longer time if you want to solve this, but let's take a look at it together. So the question is derivative of 4x to the 6. So as I said before, we keep the 4, the coefficient aside, and we solve whatever's inside. So with x to the 6, we bring the 6 to the front, x, and we do 6 minus 1, which is going to be 5. And we multiply 6 times 4. It's going to be 24 x to the 5. And boom, that's the derivative. So now let's combine everything that we learned and see if we can derivative of something that has both a constant and an exponent. Okay, for this question, try it out yourself before you continue. Okay, so let's take a look at this question. We have two essential parts to this question. We have the exponents that we worked with, and we have the constants that we worked with. And when you're trying to solve this question, you can actually break up the question into those two different parts to make it easier. So let's work with the exponent part first. So what do? We bring the exponent down, and we subtract it by 1. So let's take a look at how it's going to be. So we have 9 multiplied by 6x, and what's 6 minus 1? It's going to be 5. So that's that part, and we just forget about it for now. Now let's go on to the constant part. So what do we say the derivative of any constant was? 0. So simply, we just put plus 0. And now we can simplify that. 5 multiplied 9 times 6, which is 54 x to 5. Now to final answer. The derivative of this whole thing is essentially 54x to the 5. Let's do one more complicated question to see if we truly grasp the concept of derivative. Take a look at this derivative. 6x squared plus x minus 54. Pause the video, try it out yourself, and let's take a look at it together. Okay, so there's 3 different parts of this question essentially. And so we can look at this question as 3 different questions. We can just combine together at the end. So let's take a look at 6x squared. We've run these type of questions before. What we do is put the 6 out in front, work on the exponent to bring out down to 2x. What's 2 minus 1? Just going to be 1. So we can also write it as 2x. Now let's go on to this part. So it's similar to what we did, but there's no exponent. So what did I say that when doing an exponent, we indicate a 1 here, right? So let's do the same exact thing that we would do. So we have plus, and we bring on the exponent down. So it's going to be 1. We write the x. We subtract whatever the exponent is by 1. It's going to be 1 minus 1. Right? And let's simplify this a bit more. That's going to be 1 minus 1 is going to be 0. So it's going to be 1x to the 0. And what is anything to the power of 0? It's going to be 1, right? So you can simplify that even further, and that is going to be 1. So we're essentially doing 1 times 1. And we have the negative 54. Well, we know that any constant is going to be 0 for its derivative. We want to simplify this question. So we have 6 times 2x, that's going to be 12x. What's 1 times 1? This will be 1, plus 1, and minus 0. This is going to be 0. So the derivative of this is going to be 12x plus 1. And that is the derivative done. Leave a like and subscribe, and please tell me what topic you want to cover next.